All right. Let's move on to the next piece of this. We're going to look at simple radical form. And this is when I ask you to simplify something under a radical. There are three things you got to watch out for. Is the radicand of an nth root containing no nth powers as factors? That is about the most complicated way to say that. Basically, it means that if you have, let's say you have b. I'm trying to think of the best way to put this. I'm just going to give you a number. Okay, let's just give you a number. Let's say I take the square root of 20. 20 is not a perfect square. 20 is not something multiplied by itself to get 20. There's no number that you can multiply by itself and get 20 that is a perfect square, that is a whole number. So what I have to do is I have to simplify this. Now, to simplify this, what I need to do is make sure there are no numbers, no factors of 20 that I can take the square root of. That's what this number 1 in Roman numerals is referring to. It means you have found every factor of 20 that can be taken the square root of, and you've done that to it. The way we do that is we say that square root of 20 becomes the square root of 4 times 5. Well, 4, we can write square root of 4 times the square root of 5. That is permissible. And the square root of 4 is actually 2. So we get 2 times the square root of 5. Now this is the radicand of an nth root contains no nth powers as factors. The 5 contains no factors in it that you can take a square root of. The 20 includes a 4, which you can take the square root of. All right. Now we have, that was number 1. Then you have number 2. The root index is as low as possible. Now that's a little more complicated. The root index is as low as possible. It almost sounds like you can change the root index. But in reality, you can. That is perfectly permissible if you do it using the proper reduction of fractions. Let's say that instead of giving you up here where I gave you 25 and 3/2, what if I gave you, say, 4th root of 25 raised to the 6th power? Well, that looks kind of complicated, doesn't it? But remember, the index, that number 4, is actually a fraction of an exponent. It's the denominator of the fraction in the fractional exponent. So we can rewrite this 25 and put a 4 in the denominator. And that 6 has to be the numerator. Well, when I look at this, 6 over 4, I know we can simplify that. We can simplify that very easily, and it becomes 25 to the 3/2. Now what I've done is I have taken that 4, which is an index, used the exponent of a 6, and I've used it to be able to reduce it down to the smallest possible index, which means it is actually the square root of 25 raised to the 3rd power. So number 2, when they're talking about the root index is as low as possible, this is what they're looking for. They want you to find out, can you reduce the fraction? Can you make it smaller? Because the smaller the index, the easier it is to do the root, or the easier it is to handle the radical. Now, the last one, you need to make sure there are no radicals in the denominator of a fraction, and I'm not talking about your exponent fraction. I'm talking about in the actual function itself. Like say, if I gave you, say 6, square root of 6, actually, let me rephrase that. Let's say that instead I give you 9 over 5, and I want to take the square root of this. Well, if you take the square root of 9 over 5, you're really taking the square root of 9, and you're dividing it by the square root of 5. There's a problem here. I can take the square root of 9, but I can't take the square root of 5 because 5 doesn't have a square root. So let's rewrite it as 3 over the square root of 5. Now I need to get rid of that radical that's in the denominator. The way I can do that is remember that any expression can be multiplied by 1. So I can multiply this by 1. Well, I can rewrite that 1 as the square root of 5 divided by the square root of 5, because anything divided by itself is 1. Now we get 3 times the square root of 5 over square root of 5 times square root of 5. Well, that's 5. I'm squaring the square root of 5, so the square root goes away and I'm left with 5. And now I have a number, an expression that doesn't have the square root or any radical in the denominator.